All right, so today my project is on Plasmodium falciparum and Plasmodium vivax malarial resistance and the Duffy FY antigen. And it's by Isha Kumar. That's me. So, a brief history on malaria. So, malaria, the term, comes from mal area, which is bad air. And it's because people used to think that malaria was derived from bad air. But this was disproven by Alphonse Laverne in 1880. And he discovered that malaria is from a parasite. So it was through infection that people were getting malaria. And then in 1897, Ronald Ross had followed up on the study, and he found that there was a mosquito vector. And in epidemiology, a vector is the transmission through parasites. And in this case, the parasite would be mosquitoes. And both of them ended up receiving a Nobel Prize for their discoveries. So what is malaria? Malaria is a life-threatening disease found in tropical environments. So it's usually found in tropical Africa, Southeast Asia, and some parts of tropical America. And the reason they're found in tropical environments is because there's a high mosquito population in these environments. And also, I'm going to talk about later about the life cycle of malaria. And one of the parts is the developmental stage of malaria in mosquitoes. And the tropical environment really just facilitates this stage, so it makes it more common. So malaria does not spread from person to person, but rather through parasitic infection, so strictly through mosquitoes, and it is preventable and curable. All right, so this is a big overview of the life cycle of malaria, and honestly, I think it's kind of confusing, so I found a more simplistic version of it. As you can see, there's 1, 2, 3, 4, 5, 6 stages to it, but they can actually be simplified further into 3 stages. So the first stage is the mosquito stage, and this is where the virus becomes attained and is developed by the mosquito to be transferred to the human host. The parasite needs time to develop before it can be transmitted. And then we move, so it gets infected into the first person, and then it infects the liver cells. So this is the liver stage. And this is where the parasite regenerates in the liver and creates a waiting stage. So you'll see that there's an asymptomatic period where people aren't having symptoms. And this is because malaria is rapidly regenerating. And it has to incubate for a certain amount of time for it to become so common that it bursts into the bloodstream. And then that leads us to the next stage when malaria enters the blood. So this is when the red blood cells become infected and they start going through asexual reproduction of malaria within the blood cells, and that causes the blood cells to rupture. Yeah. Also, for the longest time, people were aware that malaria had incubated in a part of the body, but they weren't sure that it was the liver, and then that was a huge discovery. So for symptoms of malaria, they can be mild or life-threatening, and as I'm going to talk about later in this project, the mild or life-threatening, they correspond with different versions of the disease or different variants. And so mild symptoms can be fevers, chills, headaches. The severe symptoms can be fatigue, confusion, seizures, and difficulty breathing. So symptoms start 10 to 15 days. So this is similar to the regeneration of the malarial cells in the liver that I was talking about earlier. Also, malaria affects many areas of the bodies because it's a multi-organ disease, and you can see here I have central spleen, stomach, blah blah blah. So this is because malaria affects the blood, and therefore the blood affects these multiple organs. So generally for diagnosis, they use RDT or PCR tests, which is like similar to COVID, like the rapid test and the PCR polymerase chain tests. So as you can see to the right, there's an image of a blood sample, and this is a malaria infected patient. And you can see with the stain that there's a red blood cell that's being affected by malaria. And this is a really useful method to like kind of give a visual for how the patient is experiencing malaria. It's also really important for us to study malaria because for the longest time there was no widely known cure that worked on all strains of it. So, yeah. So here's a couple ways that they prevent malaria. So there's vector control, prophylaxis, preventive chemotherapies, vaccine. But basically, these are all different methods that they're essentially using to block transmission, block infection, and block disease. And you can see there's a variety of preventive and treatment options. And treatment is based off of the type of malaria you have, whether the malaria parasite is resistant to a medicine, the weight or the age of the person, and whether the person is pregnant or not. This is one example of a medication that they use, which is doxycycline. This is a common antibacterial that I don't think is specific to malaria, but has been used to treat malaria. And finally, what this class is all about. Evolution of malaria. So there's two common types of malaria. There's the falciparum malaria, and then there's the vivax malaria. So to the right, I have an image that's like kind of indicating where these variants are found. So the top image is showing the falciparum malaria, and the bottom is showing vivax. And as you can notice that they're in the same regions of the world, like in tropical regions, but the vivax malaria is less commonly found in some places, and vice versa. So the falciparum is like a more recent version of the malaria. It has more severe symptoms. It's thought to be more related to chimpanzees and gorilla versions of malaria, and originated around 5,000 years ago. And the vivax malaria is thought to be more distantly related and was found in humans approximately 40,000 years ago. Malaria has been affecting primates for millions of years, but we weren't affected by it until recently. So Duffy FY. So Duffy FY was first discovered in 1950 in a patient named Duffy, which is where the name came from. And Duffy had received multiple blood transfusions that created an antigen to the blood type Duffy. So the different antigens of Duffy appeared as A, B, and O. So they only had found one allele, but then later they discovered the A, B, and O alleles. So at the bottom of the slide, I have some general information about Duffy. So Duffy is located on chromosome 1, more specifically 1q23.2. So this is the band region, subband of the chromosome. And then the gene's name is ACKR1, atypical chemokine receptor 1. And the function of Duffy is to create DARK, essentially. DARK is like a receptor that attaches to red blood cells, and it accepts the vivax form of malaria. So the reason that this is relevant is because people with Duffy O are resistant to vivax malaria because Duffy O is not producing DARK, so there's no receptors to accept the vivax malaria, so they are resistant. but Duffy A and B are susceptible to Vivax malaria because they express the dark antigen on the red blood cells, causing the binding of malaria to the receptors. So they also found an epidemiological pattern that Duffy antigen might need to be present for malarial invasion. And they actually went back on that recently, because they said that some strains may be adapting to invade without Duffy antigen. So the creation of dark on the RBCs are like not necessary for the Vivax malaria to invade the red blood cells, which is like kind of scary. So it's more important than ever to study prevention and create new treatments. And this is like a modern day implication of how evolution exists in our world. So, yeah. Goodbye.